Leading voices in tech say that 2025 is the year of AI agents and the world is about to change forever. If you want to contribute to this next wave of AI innovation, then stick around because you will learn what AI agents are and how to build them with no code. We will also connect these agents to tools as well as form AI agent teams, or what I call agentic organizations.
So this is the year of AI agents. When we look back at this event years from now, you're going to remember it as the year of AI agents.
To do different things. So I think we're going to live in a world where there are going to be hundreds of millions and billions of different AI agents, eventually probably more AI agents than there are people in the world.
Our industry is, call it about $1 trillion, and it's an industry of tools. Computers, software, they're industry of tools. For the very first time, this is going to be an industry of skills. And you capture that phrase and you call it agents, but it's going to be for the very first time agents sitting on top of tools, agents using tools. And the opportunity for agents is gigantic.
In the next year, you're going to see very large context windows, agents, and text to action. When they are delivered at scale, it's going to have an impact on the world at a scale that no one understands yet.
I'm the founder of AgenticOrgs.com, a no-code platform for building AI agent teams that are connected to tools. Behind the scenes, AgenticOrgs builds a LangGraph.js application for you. LangGraph.js is a library for building multi-agent workflows. An AI agent is a smart digital assistant that can understand what is happening in its environment. It can make decisions as well as take actions to accomplish specific tasks. It can do all of this without requiring the user to tell it what to do every step of the way. This is different from traditional software that needs a user to do specific actions in order to accomplish tasks. An AI agent has three main components: a large language model for decision making, memory to remember what it did and what still needs to be done, and an environment that it can act on as well as get feedback from its actions. We are going to build this coding AI team that you see on the screen. But first, let's create a simple search agent. Navigate to AgenticOrgs.com. AgenticOrgs is in an open beta, so you can follow along if you'd like. Start with our free plan, which offers 1,000 workflow execution credits, so you can test and explore our features at no cost. Our plans do require you to use your own API keys. Rest assured, your API keys are encrypted. After selecting a plan, you can navigate to the dashboard homepage. Let's begin by clicking on the New button to create a new org. An org in this context is an organization of agents and tools. After clicking Save, your org will open. Notice the input node and end node on the canvas. Over on the right-hand side, click on the Toolbox tab and the Nodes sub-tab. Drag the agent node onto your canvas. To give our agent the ability to search the web, click on the Tools sub-tab, then drag and drop the Tavily Search tool onto the canvas. Connect the input node to the agent node, then connect the agent node to the Tavily Search tool and the end node. To configure the agent, click the Edit icon on the agent node. Choose your preferred provider and model. If you plan to test your agent using voice mode, select the appropriate voice mode level and enter an 11 Labs voice ID. In partial voice mode, only key parts of the agent's response will be spoken aloud. In full voice mode, the agent will vocalize the entire response. Write a description and a system prompt for the agent. A system prompt is a set of instructions that define how an AI model responds to user queries. Set the temperature, which controls the randomness of text that is generated by the model during inference. Then click Save. Next, we need to set our API keys. Click on the API keys icon on the left menu. Set the API key from the provider you selected. For this example, it is OpenAI. For Tavily Search, you'll need an account at tavily.com. If you'll be using voice mode, enter your 11 Labs API key as well. Copy and paste your keys, then click Save. Navigate to the dashboard homepage and view your org. Our agent is ready to be tested. Type a message in the chat input at the bottom right of the screen, or hold down the mic icon to speak. Let's start with a simple hello.
Hello, how can I assist you today?
Okay, now let's try what's the weather in Cape Town. Note that when the org is executing, you'll see the active nodes being highlighted.
The current weather in Cape Town is sunny with a temperature of about 20.7 degrees or 69.2 degrees. The wind is blowing from the south-southwest at 17.6 km/h. It's a clear day with no precipitation and the humidity is around 65%.
Congratulations! You've built your first agent and connected it to a tool, all without writing a single line of code. Now, let's take things up a notch and build a coding AI team that has a computer as its environment. I am a programmer, so for this video, we are solving a problem that I know well. Let me know in the comments what problems you want to solve with AI agent teams. When coding with AI, you typically request some code, run it, and then manually provide feedback when errors occur. This process involves a lot of copying and pasting between your project and the AI. But what if the AI could access your project files directly? That would eliminate much of the manual work, allowing for a smoother, more automated coding experience. First, a quick disclaimer. Building a coding AI team requires a computer to be the environment of the agents. This approach is experimental, so proceed with caution because large language models still make mistakes. I highly recommend using a virtual machine or a computer you're not worried about, just in case something goes wrong. From here moving forward, you can just watch. For my early adopters that want a dev team working on their local files, then continue following along. Before we build our dev team, let's understand how memory works in an AgenticOrg. Each org graph you create has a state. The state includes information on the structure of the graph as well as the message history. By default, there will be a messages option in the state schema. You can modify it by adding other options. The state will be the input schema to all nodes and edges in the org graph. All nodes will emit updates to the state, which are then applied using the specified transition rule. Now that we know about the state, let's transform our search org to be an actual dev team. We will need two more agents, an API dev and a UI dev. The dev team that we are creating will work on the AgenticOrgs project so that one day it will be a self-improving and self-maintaining application. That is the dream, and I believe that AI teamwork will make the AI dream work. After adding the agents, adjust the node positions so that everything can be visible. You can simply click on the node and drag it to your ideal position. Now, let's connect the agents, link the dev manager to the API dev, and add a reply link from the API dev to the dev manager. This forms a loop. You can limit the loops by setting a loop limit on the links. Create the same loop for the UI dev. The manager will give tasks to the dev agents. The dev agents will execute tasks. The manager will also be a reviewer of what the sub-agents have created and can request changes. Next, we need to configure the agents and give them proper system prompts. I am going to copy and paste in the prompts that explain the tech stack of the AgenticOrgs project. For the front end, we used Angular 19 with server-side rendering and Tailwind CSS for the styling. For the backend, we used Nest.js, MongoDB, and GraphQL code-first architecture. You can customize the system prompts to use the tech stack that you want. Once you are done editing the agent, click Save. The agents have multiple links. This will make all their links conditional edges. When you click Edit on a link, you can see a Conditions tab on the Edit Link form. To communicate to a specific agent, the dev manager will use @agent_name. You can modify this condition to whatever you want. If the condition of a link is met or is true, the agent it is pointing to will get executed with the current state. If none of the link conditions are true, it will default to calling end execution. For the tool links, the condition will have a value that detects if the last message is a tool call. When the dev manager wants to stop the org run, it will use @end execution. You can change this to something like @stop. Just inform the agent to use @stop in the system prompt. The links can be moved to a different position on a node. Click the edit icon on the link and click Move Link in the form. The node indicators will be highlighted. You can select a different indicator position to move the link. Let us add tools for the agents. We need file system tools and a CLI tool. You can use a toolkit node to group common tools. For this dev team, the tools that read will go in the reader's toolkit, and the tools that write will go to the writer's toolkit node. Add the tool first on the canvas, then drag and drop it into the toolkit node. Toolkits help make complex org graphs look more organized, and it reduces the link count. For the reader toolkit, we will add a tool to search inside a file, a read file, list files, and find files tools. These tools will give the agents the ability to gather information about the code base they are working on. It's important for agents to read a file before modifying it. For the writer's toolkit, we will add a create file tool and an edit file tool. These will allow the agents to make changes to the project. We will also add a command line interface tool, which will be used for running Git, Angular, and Nest.js commands. Let's adjust the node positions so that everything is visible. After adjusting the node positions, make sure you save your changes by clicking the save icon at the bottom left of the screen. We can now connect the agents to the toolkit nodes, connect the UI dev agent to the readers and writers toolkits, then do the same for the API dev. Our agents are now connected to some powerful tools. We need to make one final adjustment to the file system tools. The file system tools have two modes, Cloud File System and PC File System. The default for the tools is Cloud File System, which can be used if you do not want to connect agents to your local PC. The Cloud File System does not have a file browser yet, so for this demonstration, we need to edit the file system tools to use the PC File System mode. Click on the edit icon on the tool, make the change and click Save. Next, let's install the desktop app to give the agents a PC environment. On the left menu, click on Local Computers. Here, you can download the desktop app. Currently, we only have the Windows build available for download. If you need a build for the other platforms, let me know in the Discord community. After downloading the application's zip file, you can unzip it and run it. You will see a smart screen message. Just click More Info and run anyway. The desktop app is still in the early development stage, so it is not signed yet to prevent the smart screen warning. Go through the installation setup steps and then click Finish. Once installed, you can open the app. The desktop app is made with Electron.js. It gives the agents a file system, CLI, and code execution capabilities via Docker. We are working on adding a mouse, keyboard, and screen reader tools to allow us to build our own operator agents with no code. The desktop app requires an authentication token to work. You can copy the token on the computer's page, paste the token into the app, and click Submit Token. This will establish a secure connection between your agents and the app. Next, select the directory that the agents should work in. It is good to limit the files they have access to by having a specific folder for the agents. Once the folder and auth token are set, you can navigate back to the dev team you created. Switch back to the website. Click the dashboard home icon, then open your dev team org by clicking the eye icon. Once opened, you will see a label that shows that the PC is connected. Okay, let's test it. Click on New Chat to create a new session. I am going to request both agents to do a git pull in their respective folders. They will use the CLI tool. They will also create a new branch called CRUD tasks. I am going to paste in the prompt and click Send. Watch as the active nodes and links light up. You will see the manager delegating the tasks. Also notice that the dev agents are calling the tool and respond when they have completed their tasks. Tool calls can sometimes take a while to execute, but once the tool has responded, the agents continue. This was a multi-step request, and the dev agents managed to do it. The agents will respond with their voice once the tasks are completed. Like I said earlier, in a couple of years from now, we could have self-maintaining software applications. I am planning to achieve this for AgenticOrgs before the end of the year. With the recent release of the thinking models like R1 from DeepSeek and O3 Mini from OpenAI, the use cases for agentic organizations have increased. I am out of time, so in the next video, we will put this AI team to work to create new functionality for AgenticOrgs? Let me know in the comments what features you want to see next. Thanks for watching.
The git pull in the UI folder was successful, and the branch CRUD tasks has been created. Both tasks are now complete.